Welcome to this spoken tutorial on Linux file attributes. The prerequisite for this tutorial is to create empty file named as example1, example2, example3, example4, example5 and testchown. Please create empty directories named as test_chown and directory1 also. A file attribute is metadata that describes or it associated with a computer file. File attribute is a characteristics that describe a file such as owner, file type, access permissions, etc. chown command is used to change the ownership of a file or directory. This is an admin command. Root user only can change the owner of a file or directory. The syntax of the chown command is chown space options space owner name space file name or directory name. We may give the following options with chown command: -r to change the permission on files that are in the subdirectories of the directory that you are currently in. -c change the permission for each file. -f prevents chown from displaying error messages. Now we will look at some examples. So go to the terminal. We will move to the directory where we have created empty files and folders. For that, cd space desktop /file attribute and press enter. Now type the command ls space -l space testchown, that is testchown, and press enter. Here you can see the owner of the testchown is Shahid. To change the owner of the file, type the command sudo space chown space anusha space testchown, that is testchown, and press enter. Enter the sudo password and press enter again. Press enter. Now type ls space -l space testchown and press enter. Here we can see the new owner of the file is Anusha. Now we will see how to change owner of the directory. Type the command ls space -l and press enter. Here we can see the owner of the directory test_chown is Shahid. To change the owner of the directory, type the command sudo space chown space -R space anusha space test_chown, which is directory name, and press enter. Enter the sudo password if required and press enter again. I will clear the screen by pressing Ctrl L for our convenience. Now type ls space -l and press enter. Here we can see the new owner of the directory is Anusha. chmod command is used to change the access mode or permissions of one or more files. Syntax of the chmod command is chmod space options space mode space file name. We may give the following options with the chmod command: -c print information about files that are changed. -f do not notify users of files that chmod cannot change. There are following types of access or permission: R, that is read; W, that is write; X, that is execute; S, set user or group ID. Alternatively, we may specify permission by a 3-digit octal number. The first digit stands for owner permission, the second stands for group permission, and the third stands for other permission. Permissions are calculated by adding the following octal values: 4, that is read, 2, that is write, 1, that is execute. Now we will look at some examples of chmod. Move to terminal and enter the command to add execute by user permissions to file example1. Before that, I'll again clear the screen by pressing Ctrl L. Now let's type chmod space u plus x space example1. Press enter. Now type ls space -l space example1. Press enter to see the changes. Here you can see, to assign the read or write or execute permission by owner, read or execute permission by group, and execute only permission by others to file example1. Now type the command chmod space 751 space example1. Press enter. Now type ls space -l space example1 and press enter. Here we can see that above command has assigned read or write or execute permission by owner, read or execute permission by group, and execute only permission by others to file example1. To assign read only permission to file example1 for everyone, type the command chmod space equal to r space example1 and press enter. Now type the command ls space -l space example1. Press enter. Here we can see that the read only permissions have been assigned to file example1 for everyone. To change the permission recursively and assign the read and execute access for everyone and also write access for the owner of the directory1, type the command chmod space -R space 755 space directory1. Press enter. Now type ls space -l. Press enter to see the changes. To give the user execute permission on file example2, type the command chmod space u plus x space example2. Press enter. Now type the command ls space -l space example2 and press enter. Here we can see the execute permission has been assigned to user on example2. To add the right permissions to the group for file example3, type the command chmod space g plus w space example3. Press enter. And now type ls space -l space example3. Press enter. Here we can see the right permissions has been added to group. To remove the right permissions for all, type the command chmod space a -w space example3. Press enter. Now type ls space -l space example3. Press enter. Here we can see The write permission for all has been removed. chgrp command is used to change the group of one or more files to new group. New group is either a group ID, number or a group name located in /etc/group. Only the owner of a file or a privileged user may change the group. The syntax for the chgrp command is chgrp space option space new group space files. Let's go to terminal. Now we will look at some examples of chgrp command. Type the command ls space -l space example 4. Press enter. Here we can see the group permission is for user Shahid. To change the group permission, type the command sudo space chgrp space Rohit space example 4. Press enter. Enter the sudo password if required. Now type the command ls space -l space example 4. Press enter. Here we can see that the group has changed from Shahid to Rohit. The inode number is a unique integer assigned to a device. Inode stores basic information about a regular file or a directory. All the files are hard links to inodes. Whenever a program refers to a file by name, the system actually uses the file name to search for the corresponding inode. We can use ls space -i command to see the inode number of a file. Type the command ls space -i space example 5. Press enter. Number written before the file is the inode number of the file. Inodes are associated with precisely one directory at a time. Hard links are to associate multiple directory entries with a single inode. ln is the command to make link. The syntax of ln command to create the hard link is ln space source space link, where source is an existing file and link is the file to create. Now we will look at some examples of hard link. Let me clear the screen again. Now type the command ln space example1 space example ln. Press enter. To display the inode number of both the files, type the command ls space -i space example1 space example ln. Press enter. Here we can see that inode number of both the files are same. File example ln is the hard link for file example1. Soft link, symbolic link, is a special type of file that contains a reference to another file or directory in the form of an absolute or relative path. The syntax of ln command to create soft links is ln space -s space target file name space symbolic file name. Now we will look at some examples of soft link. To create the soft link, type the command ln space -s space example1 space example soft. Press enter. Now to display the inode number and list of both the files, type the command ls space -li space example1 space example soft. Press enter. Here we can see that inode number of both the files are different and example soft is soft link of example 1. So in this tutorial we have learned about the Linux file attributes like changing permission, ownership and group of a file. We also learned about the inode, soft and hard links of a file. This brings me to the end of this spoken tutorial. Spoken tutorials are a part of Talk to a Teacher project supported by National Mission on Education through ICT. More information on this is available at this following link. This is Anusha Kadambala and Shahid from IIT Bombay signing off. Thanks for joining.
Welcome to the spoken tutorial on redirection and pipes. This is Abhijit Sunil. I'm using Ubuntu 10.04. We assume that you already have an idea about the Linux operating system and have some basic idea about commands. If you're interested, it is available through another spoken tutorial on the following website. Also note that Linux is case sensitive. All the commands used in this tutorial are in lowercase unless otherwise mentioned. Most of the work that we do in Linux is through a terminal. When we have to execute a command, we generally type through the keyboard. Say we have to find the date and time. We simply type through the keyboard date and press enter. So we normally give input through the keyboard. Similarly, we see that the output of our command is also displayed at the terminal window. Also say some error occurs while we are executing some command. For example, we type cat space AAA and press enter. Now, no such file by the name AAA exists, so there is an error displayed saying so. Now this error also comes on the terminal window, hence we see error reporting is also at the terminal. Now inputting, outputting and error reporting are the three special actions related to commands. Before learning about redirection, we should know about two important concepts, that of stream and file descriptor. A Linux shell like bash receives input and sends output as sequences or streams of characters. Each character is independent of the one before it and the one after it. Streams are accessed using file I/O techniques. It does not matter whether or not the actual stream of characters comes from or goes to a file, a keyboard, a window, etc. In Linux, every opened file of a process is associated with an integer number. These numeric values are known as file descriptors. Linux shells use three standard I/O streams. Each of them is associated with a well-known file descriptor. stdin is a standard input stream. It provides input to commands. It has file descriptor 0. stdout is a standard output stream. It displays output from commands. It has file descriptor 1. stderr is a standard error stream. It displays error output from commands. It has file descriptor 2. Input streams provide input to programs. By default, it takes from terminal keystrokes. Output streams print text characters by default to the terminal. The terminal originally was an ASCII typewriter or display terminal, but is now more often a text window on a graphical desktop. We have seen that the three streams are connected to some files by default, but in Linux we can change this default behavior. We can connect these three streams to other files. This process is called redirection. Now let us see how redirection is done in the three streams. First, let us see how the standard input is redirected. We redirect standard in from a file using the left angle bracket operator. Let us see how. We know that the use of wc command is to find the number of lines, words and characters in a file. Type wc on the terminal window. Now press enter. What happens? We have a blinking cursor. It means that we need to enter through the keyboard. Enter some text. Say, this tutorial is very important. Now press enter. Now press Ctrl and D keys together. Now the command will work on the lines that we entered. The command will give an output on the terminal. Now here, no file is given after wc command, so it takes input from standard input stream. Now the standard input stream is by default connected to the keyboard. Hence, wc will take input from the keyboard. Now if we write wc space left angle bracket space test1.txt, what happens is that wc will tell us the number of lines, words and characters in the file test1.txt. Now type wc space test1.txt. We see the same result. So what is the difference? When we write wc space test1.txt, the command opens the file test1.txt and reads from it. But when we write wc space left angle bracket test1.txt, wc still does not get any file to open. Instead, it looks to pick up the input from standard in. Now we have redirected standard in to the file test1.txt. Hence, the command reads from test1, but actually it is unaware as to from where the data is coming to standard in. So we have seen how to redirect standard input. Now let us see how to redirect standard output and standard error. There are two ways to redirect output or error to a file. Suppose n refers to the file descriptor. N single right angle bracket redirects output from file descriptor n to a file. You must have write authority to the file. If the file does not exist, it is created. If it does exist, the existing contents are usually lost without any warning. N double right angle bracket also redirects output from file descriptor n to a file. Again, you must have write authority to the file. If the file does not exist, it is created. If it does exist, the output is appended to the existing file. The n in n single right angle bracket or n double right angle bracket refers to the file descriptor. If it is omitted, then standard output, that is file descriptor 1, is assumed. So, just the right angle bracket is same as one right angle bracket, but to redirect error stream, you have to use two right angle bracket or two double right angle bracket. Let us see this practically. From the last example, we have seen that the result of the wc command on a file or standard in is displayed at the terminal window. What if we do not want to display this on the terminal? We want to store it in a file so that the information can be later used. By default, wc writes its output to the standard out. The standard out is by default connected to the terminal window. Hence we see the output in the terminal window. But if we can redirect the standard out to a file, then the output from the wc command will be written to that file. Say we write wc space test1.txt right angle bracket wc underscore results.txt. Press enter. Now to see whether this has actually happened, we can display the contents of wc underscore results.txt by the cat command. Yes, it has. Suppose we have another file test2 in the same directory. Now we again execute the command with test2 file. We type wc space test2.txt right angle bracket wc underscore results.txt. So the contents of the file wc underscore results would be overwritten. Let's see this. Instead, if we write wc space test1.txt right angle bracket twice wc underscore results.txt, the new contents will not overwrite the already present contents of the file wc underscore results.txt. It will be appended. Let's see this too. Redirecting the standard error is done similarly. Only difference is that in this case we need to mention the file descriptor number of standard error before the right angle bracket or double right angle bracket sign. Like we know that there exists no file by the name AAA, write the following: WC space AAA. The shell will give the error no such file or directory. Now say we don't want error messages on screen, they can be redirected to some other file. For this we may give the command WC space AAA space 2 right angle bracket errorlog.txt. Now the error will not show on the terminal, rather it will be written in the file errorlog.txt. We can see this by the command cat space errorlog.txt. Now suppose that I make some other error by running the command cat space bbb space 2 right angle bracket errorlog.txt. The previous error would be overwritten and the new error will show. See cat space errorlog.txt. But what if we want to list all errors? Simple. We would run the command wc space aaa space 2 right angle bracket twice errorlog.txt. We'll check this using the cat command. We have seen how the three streams standard out, standard in, standard error are redirected and manipulated separately, but the real power of this concept can be caused when we can manipulate the streams together, that is, connect the different streams. This process is called pipelining. Pipes are used to create chains of command. A pipe connects the output of one command to the input of the next command in the chain. It looks like command 1 vertical bar, command 2 hyphen option vertical bar, command 3 hyphen option 1 hyphen option 2 vertical bar, command 4. Say we want to know the total number of files and directories present in the current directory. What can we do? We know ls space -l will list all files and directories of the present directory. We can redirect the output to a file ls space -l right angle bracket files.txt. Run cat space files.txt. Now each line is the name of a file or directory. So if we measure the total lines in this file, we can use files.txt to serve our purpose. This we can do using the command wc space -l files.txt. Though this serves our purpose, there are a few problems. First, we need an intermediate file, here files.txt. If the first command produces a lot of data, it may unnecessarily eat away the disk memory. Also, if we want to change several commands, this method is slow. We can do it much easily using pipes like this. We write ls space -l vertical bar wc space -l, and we can get the same result with much more ease. The output from the ls command goes as input for the wc command. We can add even longer chains of command using pipes. One common use of pipes is for reading multi-page displays. Type cd space /user/bin. So we are now in bin directory. Now run ls -l. We cannot see the output properly, but if we use it joined with a pipe to more, we can. Press enter to scroll through the list. Press Q to come out of it. These were some of the commands that help us to work with files. There are many more commands. Moreover, each of the commands that we saw has many other options. I encourage you to see more about them using the man command. The best way of learning commands is to use them again and again. This brings me to the end of this tutorial. Spoken tutorials are a part of the Talk to a Teacher project supported by the National Mission on Education through ICT. More information on the same is available at the following link. This is Abhijit Sunil signing off. Thank you.
Welcome to this spoken tutorial on working with Linux processes. I am using Ubuntu 10.04. We assume that you know how to get started with the Linux operating system and have some basic idea about commands. If you are interested, it is available through another spoken tutorial on the following website: http://spoken-tutorial.org. Also note that Linux is case sensitive. All the commands used in this tutorial are in lowercase unless otherwise mentioned. To understand what a process is, let me give you a brief explanation. Anything that is running in Linux is a process. The shell that is running and taking our commands is a process. The commands that we type on the terminal are processes when they are running. The video in which you are seeing this tutorial is a process. The browser running in which you have opened the spoken tutorial website is a process. Shell scripts that are running are processes, and so on. A process can be defined as a program which is being executed, that is, which is running. Processes are much like us. They are born, they die. They have parent and children. Let us first learn about the shell process. The shell process is started by the Linux kernel as soon as we log into the system. At this point, it would suffice to know that the Linux kernel is the core of the Linux operating system. It consists of the most essential components that makes Linux run. The shell creates or gives birth to all the other user command processes. Let us open a terminal. We can see the command prompt on the terminal in the form of a $sign. This is the job of the shell process. Now let us type any command, say date, and press enter. As soon as we do this, the shell process will create a process called date. Now, since the shell process has given birth to the date process, we can say that the shell process is the parent of the date process and the date process is the child of the shell process. Once date process has shown the system date and time, it will die. A shell can also give birth to another shell process. Giving birth to a process or creating a process is also called spawning a process. To spawn another shell process, simply go to the terminal and type sh and press enter. You would see a new prompt appearing in the terminal. Now our original shell, let us call it shell 1, has given birth to a child shell, a subshell, let us call it shell 2. Now you may run a command in this new command prompt as well. Let us run ls command in this new command prompt. Now at the command prompt type ls and press enter. We can see a list of files and directories. Now a new process named ls is created. Here shell 2 is the parent of ls, while shell 1 is the grandparent of ls. ls is the child of shell 2, while shell 2 itself is the child of shell 1. To kill shell 2, simply type at the new prompt exit and press enter. This will kill shell 2 and will get back our original command prompt. Continuing analogy between us and processes, we know that each of us has some attributes that identify us. Those attributes can be a name, parent's name, date of birth, PAN card number, etc. Similarly, processes also have attributes like PID, process ID, PPID, parent process ID, start time, etc. Most of these attributes are maintained by the kernel in a process table. Each process is uniquely identified by a unique integer called the PID. PID is allotted by the kernel when the process is born. The PID of the parent process that spawned a new process, say P1, is called the PPID of P1 process. To see the PID of the current shell, at the prompt type echo space $$ and press enter. A number would be shown. This is the PID of the current shell. The one command that we would use a lot while talking about process is the PS command. PS or process status is a command which displays the processes running in the system. Let us see what happens if we run this command without any options. Now at the command prompt type PS and press enter. This way we would normally see the list of all the processes owned by the user running the program. You can see the name of the process under CMD heading. Other than this, you can see the PID, TTY or the console at which the process is running, the time, that is the total processor time that has been used since the process started. On my machine it displays two processes. One is the bash, the shell process we are using, the other is the PS process itself. The other important thing to note here is that the PID of the shell process is same as that shown by the echo space $$ command. If we spawn a subshell, let us see what happens. At the terminal type sh and press enter. Now in the new prompt that appears on the new line, type PS and press enter. Now we can see three processes in the list. The process sh has been added. Here again notice the PID of the bash process is same as that before. PS comes with many options as we would see next. First option that we would see displays more attributes for the processes listed. Now at the prompt type PS space -F and press enter. This again will list three processes as in the previous case. Bash, sh and PS-F. The only difference is now more attributes are listed. UID gives the username of the user who has started the process. Also it shows the PPID, that is the PID of the parent process that created the process. For example, see that the bash process is the parent of sh process. So the PID of the bash is same as the PPID of sh process. Similarly, since sh process is the parent of PS process, the PID of sh process is same as the PPID of PS-F process. C stands for processor utilization. Currently this is the integer value of the % usage of the processor over the lifetime of the process. It will be displayed as 0 in this case as the usage is negligible. The stime field gives the time at which the process started. The rest we have already seen while running PS. Processor of two types. First one is the user processes. Those are started by the users. For example, PS or for that reason most commands that we run on the terminal. Second one is the system processes. Those processes are started by the system often during system startup or user login. Example of system process can be bash. Sometimes we may want to see all the processes, both system processes as well as user processes. Then we use the -E or the -A option. Go to the terminal and type at the prompt PS space -E and press enter. We can see a large list of processes. To get a multi-page display, just type at the prompt PS space -E space vertical bar space more and press enter. As we have seen before, more will cause only as many processes to be listed as can fit in one window. As we press enter, we scroll to the list of processes. The first process in this list is interesting. It is called the init process. It is the process from which almost all other processes are spawned. It has a PID of 1. To come back to the prompt, press Q. So, in this tutorial, we have learned about process, shell process, spawning of process, process attributes, and different types of processes. We also learned the use of PS command. This brings me to the end of this tutorial. Spoken Tutorial is a part of a Talk to a Teacher project supported by the National Mission on Education through ICT, MHRD, Government of India. More information on the same is available on the following link: http://spoken-tutorial.org/nmeict-intro. This is Prashant from IIT Bombay signing off. Thanks for joining.